Hello students, hope you are doing well. Let us start with our new physics topic 06 Error in Measurement.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Let us discuss our first question here. Describe error. Inaccuracy in measurement of physical quantity is called error. There are two types of error. One, systematic error. Two, random error. Later we'll discuss in detail about systematic and random error. Next question is define accuracy of measurement and precision. The accuracy of measurement is a measure of how close the measured value is to the true value of the quantity. Precision tells us about the resolution or the limit to which the quantity is measured. Next question is describe systematic error. Systematic errors are those errors which tend to be in one direction, either positive or negative. Such errors cannot be both positive and negative simultaneously. Some of the sources of systematic errors are as below. First, instrumental error. This type of error arises due to imperfect design or improper calibration of the measuring instrument. For example, spring balance pointer showing 0.1 gram instead of 0 gram by default. Second, error due to imperfection in experimental technique or procedure. External factor like temperature, pressure, humidity can produce systematic error in measurement. Third, personal error. Such an error arises due to an individual bias, carelessness in taking observation or improper setting of apparatus of the experiment. Systematic error can be minimized by improving experimental techniques, selecting high quality instruments, and removing personal bias. The next question is describe random error. The random errors are those errors which arise due to irregular and unpredictable fluctuations in the factors affecting the measurement during experiments. These type of error can be both positive and negative. Such errors can be estimated by taking many observations and then taking their mean or average. Next question is describe estimation of errors in detail. A. Absolute error or average absolute error. The magnitude of the difference between an individual measurement and the true value of the quantity is called absolute error of the measurement. The arithmetic mean average of absolute error is called average absolute error. B. Relative or fractional error. Relative error is the ratio of the mean absolute error to the mean value of the quantity measured. C. Percentage error. When the relative error is expressed as a percentage, it is called percentage error. Please follow the numerical portion for this topic. That is a separate video where all the numerical types are dealt according to topic wise. Our next question is a derivation. Derive an expression for the following: errors in sum and in difference. Errors in sum. Suppose two physical quantities A and B have measured values A plus minus delta A and B plus minus delta B respectively, where delta A and delta B are their absolute errors. We wish to find the absolute error delta Z in the sum. We have by addition Z is equal to A plus B. Therefore, Z plus minus delta Z is equal to A plus minus delta A plus B plus minus delta B is equal to A plus B plus minus delta A plus delta B. Therefore, the maximum possible absolute error in Z delta Z is equal to delta A plus delta B. For the difference, Z is equal to A minus B, we have therefore Z plus minus delta Z is equal to A plus minus delta A minus B plus minus delta B. A minus B plus minus delta A minus plus delta B. Therefore, delta plus minus delta Z is equal to plus minus delta A minus plus delta B. Here there are four possible values: plus delta A minus delta B, plus delta A plus delta B, minus delta A minus delta B, minus delta A plus delta B, in which plus delta A plus delta B is the maximum value. Thus, the maximum value of absolute error in Z is again delta A plus delta B. Therefore, the rule is when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute error in the individual quantities. Our next question is also on expression. Derive an expression for the following: errors in product and in division. In this case, we have shown you the expression for the product. Division can be derived in the same way. Please try on your own for division. Suppose A is equal to A and B, and the measured value of A and B are A plus minus delta A and B plus minus delta B. Then Z plus minus delta Z is equal to A plus minus delta A multiplied by B plus minus delta B. When we multiply this expression, AB plus minus delta plus minus A delta B plus minus B delta A plus minus delta A delta B, dividing LHS by Z and RHS by AB, we have 1 plus minus delta Z by Z is equal to 1 plus minus delta A by A plus minus delta B by B plus minus delta A by A into delta B by B. Since delta A by A and delta B by B are very small, we shall ignore their product. Hence, the maximum fractional error in Z is delta Z by Z is equal to delta A by A upon plus delta B by B. Similarly, division rules can be derived. Therefore, the rule is when two quantities are multiplied or divided, the maximum relative or fractional error in the result is the sum of the fractional error in each quantity. Our next question is derive an expression for error due to the power index of measured quantity. Suppose Z is equal to A to the power Z is equal to A into A. Then delta Z upon Z is equal to delta A upon A plus delta A upon A is equal to 2 delta A by A. Hence the fractional error of Z is equal to A square is 2 times the fractional error of A. Same way, Z is equal to A to the power n, then Z by delta Z by Z is equal to n into delta A upon A. In general, if Z is equal to A to the power P, B to the power Q, C to the power R, then delta Z by Z is equal to P into delta A upon A plus Q into delta B upon B plus R into delta C upon C. Our next question is when more than one physical quantity is measured, then find the maximum error that occurs in the final result. In addition, Z A plus B, error occurred is delta Z is equal to delta A plus delta B. In subtraction, Z is equal to A minus B, delta occurred is delta Z is equal to delta A plus delta B. In division, Z is equal to A upon B, the error occurred is delta Z upon Z is equal to delta A upon A plus delta B upon B. multiplication z is equal to a into p, error is equal to delta z upon z is equal to delta a upon a plus delta b upon b. Exponential power z is equal to a to the power n, error is equal to delta z by z is equal to n to the power delta a upon a. Next question is, give the practical norms for the use of SI unit. A. Unit of every physical quantity should be represented according to its symbol. B. No full stop should be used within or at the end of the symbol of a unit. For example, kilogram, kg should be written. C. Symbols for units do not take plural forms. D. The unit of physical quantity in numerator and denominator should be written as a ratio only. For example, meter per second square or meter ms to the power minus 2. E. Full name of a unit when it is named after scientist is not written as capital letter, but the symbol for the unit has a capital letter. Our next question is, by parallax method, how can you find the distance of a planet or star from Earth? Parallax method is used to measure very large distance, such as distance between the planets, stars from Earth can be measured with the help of parallax method. To measure a distance d of a far away planet, we observe it from two different positions, observatories A and B from the Earth, as given in the below figure. For example, observing a planet P simultaneously from two points A and B situated diametrically opposite of the Earth, we get two directions of observations, AP and BP. Since the direction of the planet, since the distance of a planet from Earth is very large compared to the diameter of the Earth, angle theta will be very small. Angle theta is called parallax angle. According to the definition of angle in radian, theta is equal to arc upon radius is equal to AB upon AP is equal to distance between the two places of observation, that is B, upon distance of the planet from the Earth, that is D. Therefore, D is equal to B upon theta. Our next question is, by parallax method, how can you find the size of a planet or star? Let d be the diameter of the planet and alpha be the angular diameter of the planet. Angular diameter is the angle suspended by the diameter of the planet at any point in the Earth. The angle alpha can be determined from any given location from Earth by viewing diametrically opposite point of the planet. through a telescope. Alpha is equal to d by capital D in radian. If the distance d of the planet from Earth is known, the diameter of the planet can be determined by the above equation. In practice, angle alpha is very small. Explain monomolecular layer method. By monomolecular layer method, we measure the size of molecule. In this method, thickness of molecular layer is measured to determine the size of the molecule. For example, the thickness of a layer of stearic acid cannot be less than a certain definite value. If we assume that the film has one molecule thickness, this becomes size and the diameter of the molecule. And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.